Good evening, Marvin. How are you?
I'm fine, thank you. How are you too?
I'm doing fine, thank you very much. I'm hoping our other colleagues are going to be joining us soon. I've just reached out to the course representative and I've sent through an email reminders as soon as we have a few more of our colleagues, maybe two more perhaps. I suppose we can probably start or continue our discussion. Um, but as we are waiting for them, my thinking is we don't really have to we don't really have to be unproductive. We can at least attempt to be productive. So I was hoping that maybe we could have maybe an informal conversation centered around some of the things that we discussed last time. If at all you have any questions, um, as we are waiting, I see though that we at least there's two of you available, which is good enough. In the interest of time, I think we can start. Um, so I wanted to first of all start off with I think this is going to be an advance apology, to be honest, right? So and on my part, I think I should have made prior plans before the class, but unfortunately I did not. So it turns out that we have a brownout where I live. We're having this class I'm broadcasting from home, not from campus. In part because I was out, and so I decided to just come straight home here. So this is an advance apology in the event that I run out of power before power is restored. Ideally, power today. Um, if you check your brownout schedule, I don't know if you guys have access to the load shedding schedule, but if you look up the brownout schedule, we are section C really, and we are supposed to have power restored at somewhere around 17 hours. Right about now, we're supposed to have had power restored because I think the brownout session is supposed to be from 9 to 17. So in the event that I completely run out of power before we end class, apologies in advance. We can perhaps try and see if we can schedule another interaction. Maybe a different time slot or something. It could be maybe next week or something. I don't know. But but other than that, I also wanted to make mention of the fact that this coming week I'll be working off campus, out of town actually, and so unfortunately we will not be able to have what you might call an in-person interaction. I want to suggest that we stick to that same schedule, so we will have class, but the class will be virtual. So that's that. In the event that something changes, I'll communicate with you. But I know that the workshop that I'm attending, or the sessions at least for this coming week, are scheduled to start around 8 hours, and then we are supposed to wrap up everything around. Around 17 hours. So that should give me an extra 30 minutes to prepare for class, to transition to a different class. I'm hopeful that the venue for this same conference probably has backup plans in terms of load shedding. So anyways, I thought I'd make those two announcements. But other than that, I'm not sure if people have any specific questions centered around what we were discussing. You have to perhaps try and I'm wondering where exactly we ended here. I'm a bit embarrassed to say I've literally forgotten where we stopped off from. I normally record these sessions, and so in case people have equally forgotten, what I can do is I can quickly check the session for the 21st and try and see if we can check exactly where it is we ended. You'll notice that I think we're actually discussing I believe the EMIZ, if my memory serves me right, we're discussing the EMIZ project. So we ended up to here, right? We're discussing this. And really, in essence, what we were doing, or what we're still going to do next coming minutes here, is just to contextualize data mining. And the strategy has always been such that we try and focus on problems that we can easily relate to, or perhaps areas that we can easily relate to as well. Right. So most of these examples are either things that I have been close, or things that I'm associated with, or things that I have in the past been closely associated with. In some instances, some of the projects that I think I was highlighting are projects that students I'm working with or have worked with are actually busy with. So in addition to these projects I spoke about, and I think I spent quite a bit of time explaining the so-called Enterprise Medical Imaging Project, the MIZ project. So we spoke about the 7 work packages, and most of the work packages really are tied to data mining, right? And so I want to draw attention to things like work package number 1, which has aspects of policy, and I'm highlighting policy because if you remember the Oxford Insights AI Readiness Index report, if you remember, takes into account some of the things that you'd want to put in place insofar as policy is concerned. The other work package that involves data mining, extensive data mining, is so-called the work package that is involved with DICOM compliance. And I wish I had, I thought I had installed WASIS here. If I had a DICOM viewer, I would actually showcase exactly how this works, right? So that you have an appreciation of the complexity associated with DICOM metadata in essence. But I had highlighted the fact that, just to give you a bit of additional context, I had highlighted the fact that this notion of and I hope this will work, probably not, but this notion of DICOM metadata is similar to the things that we see at play. I'm just going to change this to projector here and say okay. They are similar to things that we see at play in regards to metadata associated to medical images, right? If I can just change this to set as default here so that it's a lot easier, and then I'll exit and come back online so that you see. There we go. So if you, and by the way, I don't know if the sound I got was a hand up or something. If it is, it's a small class. Just feel free and ask away if you have a question, or maybe I should log in with my phone as well so that I can easily check why. So this notion of DICOM metadata is tied to metadata associated with these images that we're used to, right? So if you look at this image, for instance, the thing with this was taken in the southern part of the country, right, in Siavonga, and if you look at this image, the common man or the average individual may not appreciate the fact that there is rich information associated with this. And true to that, if you were to, sorry about that, if you were to, let's say, try and view this image, right? So this image is this one here. I'm just going to copy it so that you see, right? This image is this image, right? And you notice if you use tools like, I believe it's EXIF, for instance, right? And try and open this. What EXIF would do is it would dump the embedded metadata in this image, all right? And you may not really appreciate this stuff here, but if I'm to, I don't even have to copy it across, but you notice that there are obvious things that that you're probably already familiar with, things like the file name, for instance, the unique identifier. Of course, this is contextual, right, as it relates to the location of this file, which is the directory. You also have important information like the file size of this image. And then afterwards, you begin to see very important information, right? I guess if you're a sort of individual who is into computer forensics, for instance, you agree with me that details associated with the timestamps, so the date, when this file was last modified, for instance, will actually provide you with a lot of important information. But beyond that, if we start scrolling down, you start seeing a lot of additional important information. So already we can see that this file was taken using a OnePlus phone, for instance, because the make of the device used to capture this image is actually captured, right? Including the model itself. All of these things may not necessarily be that very important, but if I start scrolling down here and I want to draw attention to perhaps important, very, very important details, like this stuff here, GPS position, right? And of course, these become important depending on what you're using this image for, right? If you're a person who is obsessed with organization of these images, you will notice that this information kind of helps in organization. So if you're using tools like, I use Google Photos a lot, what you will notice is that Google Photos will automatically detect or at least will give an approximation as to where exactly this photo was taken. Because, you have to agree with me that in this day and age, we are faced with situations where at any given point in time, when there's, and ladies and gentlemen, by the way, power has just been restored. Now, this, no pun intended, but this restores our faith in ZESCO, although they're a bit behind here by 14 minutes. We're supposed to have, restored the power. There we go, thank you. Power by 17:14 here. 17 hours, this is 17:14. So there's a delay of about 14 minutes, but nonetheless, they are forgiven, I suppose. But the thing here is there's a lot of important information here. All right. There's more information actually. what you notice is that the date when I actually got this photo is actually embedded in here. And now for the benefit of, I don't know if you've seen this, but for the benefit of, maybe I can showcase this. This is going to be a lot easier here if I showcase this stuff in action. But for the benefit of the common person who has no idea what this is all about, they don't know, right? That these devices that they're using, taking photos, random photos everywhere, you don't know that, and I want to send this to the course rep, maybe Fraser, to signal this is just a test here. But the average person will not know that the phones that we are using capture all this metadata, right? This rich information, which is why some applications, and I hope, this is me hoping that this is going to work here. If I send, I'll just say sample image used in CSC 5741 plus. If you share an image via WhatsApp, I don't know if you've noticed this, if you share an image via WhatsApp, what you begin to realize is that there's some important information that is stripped out. I don't know if people have noticed this, but maybe, I don't know if this is going to work here because this is from, so I can actually download it again, I guess, and hope that this thing is going to work. I don't know. Yeah, so I just downloaded, I believe this is the one. Yeah, I just downloaded this same photo I just shared, and already I guess we can see that there's this other photo was taken when this is the one was 38. The size has obviously changed. It's been downscaled, which does make sense. But what's especially interesting is if I try to view this information, right, again in here 2024 31, if I try and view this, what you notice is the information about the location, the GPS coordinates for the photo are not there. So WhatsApp by default will strip out all that information. But that's fine, that's okay. There's a couple of other things that WhatsApp does for obvious reasons, like if you notice the size, right? The photo this WhatsApp photo here, if I open Gwenview and open this WhatsApp photo from 2024 31, this is the same one, but what you notice is that the sizes, right? This is the same as this photo here. The sizes are different. The original photo, it's not actually the original really, because again, when I upload this, I just got this from Google Photos. When I upload it to Google Photos will downscale it, right? It's 2.2 megabytes, but then when I pass it through WhatsApp servers, all of a sudden it's 494 kilobytes, right? But a drastic reduction. But so that's that, right? And I wish maybe we can showcase Oasis installation, Ubuntu or something. Maybe we can quickly install the Oasis. I do apologize. I think hopefully we can use Snap to do this quickly so that you see, we can see the let me just see if I can install this quickly. We can see the metadata that I'm talking about, right? Rich information, to be honest. But also maybe what I can do is I can actually probably use PyDicom to do this. So what I'm going to do is I'm going to navigate to a location, but you won't be able to see the image anyway, but I'll navigate to a location that has this information, and hope that you'll be able to see this. So if I go under datasets here, we have these DICOM files here, right? I'm not really sure what modality was used to capture this information here, but I could probably say PyDicom or something. It appears they don't have PyDicom installed, which is unfortunate. I wish I could do this. I really wanted to, but maybe Oasis would be installed just now. So the idea behind these medical images, the things we were talking about not too long ago, these things here, when an examination is done, there are files, images are files, right? Those X-rays and CT scans, they're in actual fact files, and there's a standard hierarchy that is used. But the idea behind this DICOM, and I think WASIS has been installed here, but the idea behind, there we go. The idea behind this, open this up. The idea behind these images is that once an examination is being performed, there's a series of important details that are also captured, right? So it's not just, if you notice here, I'll just say accept. It appears this was is it a chest? I don't know. It says thorax, chest routine. I don't know what this is here, but it doesn't matter. Maybe we can check something else. I'm gonna close this and just check another sample medical image, and hope that this thing here is going to be better. And the point I'm trying to put across really can actually be, I can actually do this without, I think, it doesn't matter what was being captured here, but this is a spine, right? The thing here is that if you pay particular attention, what you will notice is that, what is that info thing here? I wish I could zoom, magnifying lens. That's weird. There's supposed to be anyways, there's supposed to be additional information that can actually be rendered here. Zoom type. Yeah, so if you click on that DICOM information, what you notice is that there's, I don't know if you can see this, but what I'm able to see right now, DICOM data elements are called. This is the metadata that's embedded within the image itself. So in addition to this image, there's rich information associated with the patient. And really what WASIS, the way WASIS is designed is you only have access to a bit of the information, but there's an option where you can view all the information. And what you're seeing here, all of these things here, are the DICOM data elements that have been captured. So what we've been doing in that project really is to essentially to analyze this information that you're seeing. Right, a whole bunch of information, and all of these tags by these hexadecimal representations here have meaning, right? They uniquely identify a specific DICOM element in essence, right? So we did that, right? And we're working with quite a number of DICOM data elements really, but that's that, right? So we spoke about that, and then we also mentioned that the other work package that is tied to data mining, if you will, and maybe a bit of AI and machine learning is work package number 5, which is essentially just a survey, right? We're trying to gauge the awareness of medical practitioners in Zambia in regards to AI, and then also we have work package number 6, where we have quite a bit of technically inclined activities or tasks or sub projects that we're undertaking. Like for instance, we've implemented models that are meant to help with the semi-automated interpretation of pneumonia. We've developed a software tool in the form of a plugin that ideally helps us understand how we can build systems that incorporate AI. And the approach we've taken is we're embedding AI in already existing tools in this case, right? Again, the screenshot just showcasing some sample or mock-up screens for prototype tools that have been implemented to evaluate the models associated with pneumonia that have been implemented. So 2 models have been implemented, detection model and a classification model. And all these words like binary classifier or multi-label classifier or multi-class classifier or a regression model, all of these words will make sense very, very soon when we cover the phase of the CRISP-DM model that focuses on the modeling part of a data mining project, like where you're actually extracting insights from data after you pre-process it and you prepare it for modeling. And then I also made mention of the fact that there's a work package that is being overseen by our colleagues from the University of Cape Town, and the idea behind this is the automatic generation of reports. This notion that once a radiologist, so if you remember the workflow here, we're saying that at some point a radiologist will interpret the medical image, and then after interpreting the medical image, they need to prepare a report. So write it down. And currently, believe it or not, what these experts will do is they will use tools like they'll use word processor tools like Microsoft Word, for instance, to actually type a report. The thinking around this is, instead of authoring a report from scratch, can you create scaffolds of the report? This is what work package number 7 is all about. But over and beyond that, there are other interesting things that are already being done by other people out there, especially in well-resourced public health facilities, where you are using you're actually using recording equipment, right? So you instead of authoring the report, you actually you synthesize it using audio, right? So you just speak into some device, and then there's a bit of speech to text conversion, and then you do some interesting things by way of data mining. So you're mining information that you have transcribed from the audio to text, ideally, because it's difficult for you to mine audio data, is it? If you're playing back a recording, the easiest way of mining that recording is you first of all convert it to to text rather. So speech to text conversion. It brings in a number of interesting, I think, issues that may arise insofar as Zambia is concerned, right? The fact that most of these models that will help with speech to text conversion would have been trained on maybe native English speakers. So if somebody from this part of the world who has an accent, a Bemba accent or Chewa accent, attempts to use that same equipment, what you'll notice is that the accuracy of the conversion may not be as good as the native speaker, right? So the interesting things that people can do in that area, really. So we had a discussion about that, but over and beyond, right? And I think we ended there, right? But over and beyond, you notice that there are other things. If you just think about Zambia in general, you begin to realize that problems that can in part be addressed by taking advantage of data mining all around us, really. We've gotten to a stage, fortunately, and I don't know if it's unknowingly here, but we've gotten to a stage where we are gathering and collecting so much data, a lot of data. I want you to pause and think of what is currently happening, right? Here. Just think about this, and I like using this as an example, right? Think of what's happening on social media here, right? And specifically, I want to draw your attention to the things that we see happening when you're on popular pages like this, right? 1.3 million followers. The vast majority of these are Zambians. Now, the thing to think about here is maybe, for me, one of the things that I've played around with, I guess, I'll use this as an example, is if you scroll down, right, and look at, and forget about today's post, for instance, you look at maybe, I don't know which sort of post would, a while back I did a bit of, I've created a pipeline that allows us to look at posts for a given year and look at the ones that have attracted the most attention, for instance. But maybe the JCTR one would have attracted a lot of attention, I don't know. But it doesn't matter anyway. If we look at maybe this one, right? Apparently there's somebody who's been suspended here. I didn't know about this. But 358 comments, right? Now the thing here is, if I'm part of the ruling party, now I hope, I'm hoping, right? I hope for Zambia that there are actually people that are paid. I think they are. There are actually people that are paid money to do this. But if I'm part of the ruling party, if I'm part of government, I would be interested in, for instance, gaining a sense of the perceptions for certain types of topics, right? I would be interested in looking at the overall perceptions of people And you can use social media, for instance. So you look at these comments. Out of these 358 comments, overall, what is the reaction? What are people's sentiments associated with this particular topic? Now, it could be a more serious topic, right? This, in my opinion, is not as serious as a post that has been making rounds about the BNNB, for instance. I don't know if it's you saw that, but there's details to do with the BNNB, right? And people are questioning BNNB. I know people are questioning the April BNNB. Or is it the April, the March BNNB or something? There's been a number of posts here, but instead of just randomly shooting that down, what I would be interested in as government is trying to gauge people's perceptions, right, on this particular topic. And social media is perhaps, it's not really representative of the 18 plus million people in Zambia, but it gives you an idea, right, of what people are thinking. Data mining, because guess what, right? Your colleagues, I don't know why I can't see the G Suite. I can't see it. I thought it was there. Maybe they've taken it down. I don't know. But you'd be interested in the perception, right? Gives you an idea of what's happening. And hopefully, if there are people that actually do these things, then maybe there are things that are done behind the scenes, right, to course correct. The thing perhaps that that maybe people would be interested in the most is what's happening tonight, right? Fuel prices. What's happening possibly tonight? Fuel prices, for instance. What are people's perceptions towards that? But anyways, for you to be able to analyze these things, you can't manually go through, even if you go for posts that have few comments, like 148 comments. You can't manually start looking at comments one by one, right? Because some of these comments are useless. Some of them are just tags. Like, I don't know if you're one of those people who's tagged by people, right? They just tag your name so that you see this post. You're more interested in things like this, right? So you'd harvest, ideally you'd collect this sort of information. I mean, some of these comments are obviously not just, we can have a sense here. If you look at this, I think most of them are positive, actually. This is really good and all that stuff. But there's rich comments that you'd want to analyze. Like this. I think it's a negative comment. So maybe you'd be interested in doing what's commonly called a sentiment analysis, right? Are people's comments more positive to whatever is being discussed? What proportion are negative? Out of those negative comments, what exactly are people talking about? Look at this, for instance. But anyway, ladies and gentlemen, what I'm saying here, gentlemen rather, what I'm essentially saying here is that there is more, right? So there's examples to do with social media, and I think I have sentiment analysis here. But also, there's something I've been thinking about, right? I don't know if you think about this as well. And I started thinking about this because at some point I was part of a group of academics from the University of Zambia who were invited to go and appear before a parliamentary committee. I think that committee is on science. Is it science? Is it education, science, and technology or something? Now, one of the things that drew my attention when I attended that interaction was there were people that were sitting somewhere. They were actually typing, right? So in actual fact, what those people were doing was they were they were taking minutes of what was happening. I thought it was funny, right? But of course, I thought it was funny because I don't understand that environment and how it works. But my immediate reaction was, wait a minute, we have Parliament TV now. Literally, the things happening in Parliament are streamed live, right? Both audio and video. If we are doing that, what's stopping us from doing, a bit of audio analysis perhaps? Right? Speech to text. Now, please, colleagues, don't quote me and say Lighton was saying we must not employ those people that are hard to type, right? But I don't know about that here. Because it's not, those people normally be required to do those things, I guess, when you have certain committees missing. I think if you have debates, I don't know if you also have those people, take down notes. But more importantly, the question to ask is, to what extent do they comprehensively capture everything that is discussed there? I don't know. But gentlemen, the other thing here is, now, let's be honest here, right? Targets. I always say this. If you are passing through Chongwe, I pass through Chongwe Toll Plaza a couple times a year to visit my parents on the eastern part of the country. Recently, we were working from Southern Province. I passed through Shimavala. Is it Shimavala or something? The question I always ask, I'm like, but do we really need to employ people to sit in those booths just so they can get my money, right? I give them a 20 kwacha, or I give them a 50 kwacha and they give me back change. Or I give them because yours truly, myself, I have a card now, right? There's a card that you can load money in. So that I give them the card and they give me a receipt. Is that really necessary? How much money are we spending on hiring those people? Not that, again, I'm saying we should not create jobs by employing people to man those booths here, but that process can be automated. Right? Because we know, right? When you're passing through that Toll Plaza, you can literally see that your license plate number is automatically detected. You literally see that, right? So if you can capture that information, how difficult is it for you to get money from the person who's using that vehicle? It's not difficult. There's other things like a lot of discussion centered around performance of people here. So automatic prediction of learning outcomes, for instance, there's sentiment analysis, opinion mining on social media, right? And perhaps also, I don't know here, but I always throw this in because, listen, I'm not saying that, again, you should be saying light on. There's this lecturer, data mining lecturer, who's saying we should now start mining the things that people discuss on these WhatsApp groups. No, I'm not saying that. But I mean, if we can, why not, right? What I am saying is, there are obviously certain people that are a part of large WhatsApp groups. Right? I'll give you an example of a WhatsApp group I'm a part of, right? Where you expect everybody who is part of Unzalaru to be here, for instance. 297 members. Now, the problem I have personally is, you see, there's a lot of stuff discussed. Today alone, I think, it's a pity I've 80 unread messages. Now, I'm a part of a number of other groups, right? I don't have time to read through all of these things. But the question, can we mine information and build models, for instance, that are able to help somebody narrow down on important things that are being discussed? Like in the Unzalaru group that I'm a part of, I'm not interested in jokes there are times maybe that I'm interested in jokes and memes, but half the time those things I'm not interested in, right? These videos that people are sharing, funny clips and all those things, I'm not interested in those. So can we build models that would sort of like cherry pick important posts from WhatsApp groups, for instance? And with the coming of, I don't know how many of you are using so-called communities in WhatsApp. Certainly, something like that would be of great use to the vast majority of people. I'll be surprised if there aren't people that have already built custom tools, but you begin to realize that a solution like that would be ideal for an individual, right? So you develop it as an app that somebody installs, and then when somebody installs it, it grants access to WhatsApp messages or something, right? So it throws through the messages, and then it's able to dynamically, build models that are specific for you, personalizing the use to you as an individual. Anyways, yeah. So, but again, just to mention here that the potential of data mining and its application, especially things like AI, is limitless, really, especially in the 21st century. This is one of those times where data has become an integral part of what we do, because of the average person actually gets to interact with a device that will generate data. I look at my life and everything I do revolves around my smartphone. I traveled today. I know my smartphone was capturing details of where I was, right? And I personally deliberately capture this information, in part because I like analyzing what I do, but also because I like to use some of these things as use case examples. So as I was moving around today, I know that there's swaths and swaths of information that was being captured. For instance, my location history is switched on maps. If I just look at my timeline, you begin to realize that, whoa, there's a lot of information being captured. So beyond what you're seeing right now, in essence, a timeline of what was happening today, in my case, not that I was doing anything illegal here to try and hide, what was happening today, but you can literally see what was happening here, right? I moved around quite a lot, and you can see the stops, and some of these things are not really that accurate, to be honest, but that's neither here nor there. What else? If you look at your Android device, right? Every time you're tapping around, I don't know how many of you guys know that the details of what you're doing on the phone are actually being captured, right? They are logs, right? Again, maybe you could use that to implement applications that can be used on Android devices used by children in school environments or in educational settings, for instance. But really, I think what's important to you can sit here and talk about all these different things. But what's important is to, and I'll leave this question with you here, but to ask yourself, what problems you think are important. Because when it comes to research, really, we can classify problems in two main ways, right? What problems to work on. There are things that are directly related to the ills of society. If we look at Zambia, right? Cholera, theft, but also there are things that have very little to do with society, right? And I want to call these applied data mining, right? And curiosity-driven, we call it curiosity-driven data mining or something, but it's called curiosity-driven research, right? Some of the examples I'll give you is we are out there, right? Us trying to do weird things like we are building. Now this is a whole master's student, right? Trying to build a model that is going to sort out the issue of the so-called author disambiguation. I don't know if you've heard about this. So this notion that if you try and, let's say, look at publications authored by an author called Jackson Peary, and you're interested in the Jackson Peary at UNZA, well, for starters, if you're pulling this information from a very large database like Google Scholar, for instance, or Google, we know that Jackson Peary is a very common name. The question, though, is how do we identify content specific to Jackson? Curiosity-driven research, right? It has very little to do with the problems afflicting society in Zambia in the 21st century. Well, not directly anyway, right? I would argue here that some of the things we are doing will result in people gaining access to information much, much easier, right? So if you're solving a problem to do with cholera, our model may be able to help, but you get the point, right? So something to think about here. What problems to work on is very important, and this is something you're going to have to think long and hard about as you are planning what to do next year, phase 2, right? So if you look up what people are doing, right? I don't know how many of you have heard of the SK project. There's this so-called square kilometer, I think it's called square kilometer array project. So there are certain parts of the world which are dotted with and I'll share this, by the way, these telescopes, right? And I think in Africa, I believe I don't know if Zambia is there as well, is on the list of places where this information, I mean these telescopes have actually been set up, but I do know that South Africa has a place, right, in the Karoo, right, where these things have been set up. And part of what these people are doing really is they're analyzing images from the sky. and the question to ask really is, of what direct benefit is this, right, to humankind, if you think about the problems that humankind is experiencing? But this falls under the cluster of, it's curiosity-driven research. In the future, we may get to a stage where what is being done is going to be useful. And in fact, the same argument was probably made for people that were doing research in electricity, right? And the internet. Once upon a time, these were technologies really which did not have a direct application, if you will. So in terms of impact-driven, research, there are specific areas that perhaps we've directed vast amount of resources on. And a nice way of thinking about these areas really is to think about the SDG goals, right? I don't know if you people are aware of the Sustainable Development Goals here. There are 17 of them. And a lot of obsession has gone into this because, in part, some of the funding that we receive, the grants that we receive, and the loans are tied to these SDG goals. So people that work in the health sector will tell you to say, oh, if you go to a place like UTH, you'll find that the maternity wing and anything to do with pediatrics, they have a lot more resources. They're not lacking in comparison to hospitals like the eye hospital and internal medicine, for instance. The reason is simple, right? There's a lot of emphasis that has been played on these things. What else? You can think of impact-driven studies being tied to Zambia's Vision 2030, right? Sorry, not Vision 2023, but there's Vision 2030. Everything we are doing as a country is actually tied to this. The Ministry of Finance has this document, but again, you will probably find this. I like going to the version on the Ministry of Finance. Within this document, you will find focus areas, things that we value as a country, and really what you will discover is this feeds into everything we do, right? The budgets we come up with at the end of every year are tied to this Vision 2030, 6 more years. But so that's impact-driven research, right? So what we are saying here is that you can either focus on esoteric areas, right? Things that have very little things that are not of direct benefit to the current struggles of society, or you can work on problems that would directly impact the problems associated with, in this case, is Zambia as a whole. So things like health, right? Education, poverty alleviation, right? Under poverty alleviation, I teach a social protection course, and I'm hoping that we can invite Lusambo as well. So it's a social protection management information systems course. And so in essence, the whole course is centered around how we build or how we design and implement information systems that are used in the social protection sector. Think of what happens in Zambia insofar as the social is very contentious, right? The social cash transfer program, right? This is probably one of the most well-known things associated with social protection in Zambia, but social protection involves so much more, right? People that are unable to fund their way through university or through school, for instance, have to be assisted somehow. So it turns out that there's a tool that has been implemented. It's called ZSPIS, right? ZSPIS. It's the Zambia Integrated Social Protection Information System. Now, the thing about ZSPIS is it has a number of interesting modules, but what you'll notice when somebody walks you through the process or the different processes associated with social cash transfer, like for instance, grievance management or enrollment. You won't believe this, but enrollment is almost manual. For you to be enrolled, right, there's certain metrics, there's certain information that is captured. This is currently manually captured. They'll come to your house and see, do you have a bed? Do you have a bicycle? They'll discover that I have 4 bicycles here and say, no, sir, you do not qualify to be under the social cash transfer, right? How old are you? Is there somebody who is not able-bodied in your household, for instance? Where do you currently reside, right? Currently, the enrollment process is so manual such that the community is involved, right? And so we can automate all of those things, right? Instead of having human beings to verify information that is being captured, for instance. So impact-driven research is the point I was trying to drive at. I'm not really sure if this is impact-driven, but there was a time when ZRA was in the news. Not what I was talking about a few. This is page number 104. Not what I was talking about at the very beginning of this interaction, ladies and gentlemen, when I was saying, look at this, ZRA, is trying to employ AI for accurate, data or something. This was in the news this year, right? Or is it last year? I guess I don't know. At some point last year, but as of this year, I think they've set up a dedicated department or unit that oversees anything and everything to do with AI, right? Data mining, in essence. Now, if you look at some of these things that we're toying around with, these things are not really far-fetched, right? I think it falls under the confines of impact-driven research because there's been a lot of talk. You agree with me that there's been a lot of talk about how, ZRA loses out on revenue, right? Because of tax evasion, for instance. So I think they were in the news at some point to say they were trying to see if they could use drones to try and scan for these people that would be using back roads, right? To try and evade or avoid paying tax, for instance. It gets even better. You remember how, if you look at, is it with what type of tax is associated with rentals? Does anybody know? Rental tax falls under what? Does anybody know? But things have changed. Once upon a time, if you don't have your own house, if you rent, like I do, you were obliged, I think it's withholding tax, right? You were obliged to pay withholding tax to ZRA. But the question is, and I want to ask some of you that are probably renting, how many of you actually paid rent? Now, I'll be the first one to tell you I used to pay rent. I pay withholding tax. Of course, now I don't have the choice because I pay it implicitly through my landlord. I'm hoping my landlord actually does these payments. At some point, ZRA was saying I don't know if you heard about this, right? Yes, thank you very much. There's a comment. Yes. Yes. Very audible, yes.
Thank you. I've been following the discussion.
Yeah.
Somehow you've provoked my mind in a certain way.
Yes.
And now I'm trying to find out. You spoke a little bit, at some point you spoke about the parliament.
Yes.
Where you talked about people there doing some typing, where you said, why can't we have some device to do with speech recognition or rather speech analysis? Is it audio analysis?
We'll call it can be speech or audio, it's one and the same thing. Audio analysis. Maybe, yeah.
Then later on, you went on to the issue of toll gates.
Yes.
When you talked about that, I think one of the questions that ran through my mind is, as our lecturer or as a student, master's student at UNZA, is this something which you would expect a student to do and accomplish based on the information and knowledge we are getting from the school? That is one. Then the other thing is, for some time now, this thing has not been done. Even when you talked about the WhatsApp problem, I think we are all having that problem of having too much unnecessary information reaching us, and we are failing to filter that information.
Right.
So in that regard, what has stopped, or what has prevented most of us to create these tools to solve these problems? Is it that we do not have much knowledge? Is it that the country is producing people who are not well baked to solve these real-time problems? Or is it the expectation of you, our lecturers, that at the end of these interactions, we should be able to research more and solve these problems? So in a nutshell, my question is, from the knowledge we'll get at the end of the day, would you confidently say that we should be able to solve these issues? Or you expect us as your students to dig deeper and be able to solve some of these problems? I hope my question is in order, sir. Thank you.
Yes, very much so, sir. Thank you very much. Very thought-provoking question here. And so here's the thing. I'll start off by stating something that you probably have not yet realized, right? Maybe because you have yet to have frequent interactions in some of these courses as well. But currently, right, your cohort has I don't know, I think I counted, is it almost 15? Maybe it's going to be less here, 15 people. Unfortunately, not all the 15 are going to be interested in data mining. I mean, you're doing a bunch of other courses, right? There's advanced distributed systems. There's computer security. So out of your cohort, if I was to make an educated guess, maybe less than half would be interested in data mining. In fact, maybe even 2 or 3 would be interested in doing or conducting a study that is focused on data mining. Already that's a drawback, right? Because there's a lot we can do, but we only have very few people that will ultimately, beginning next year, will be interested in doing research in data mining. You understand? So that's my explanation as to why we haven't really seen any, I want to call it, significant traction in this area, right? That's one thing. But in terms of what is expected of you at the end of your master's, remember, we're still giving context here. What you will soon realize is that between now and June, you will acquire all the skills you need to be able to undertake a data mining centric project in whatever area, be it audio analysis, image analysis, text analysis. The idea is the same, the concepts are the same. And in fact, it's part of the reason why there's a component, a practical project, we call it a mini project, that is supposed to be undertaken. And really, true to this, you realize that by the time we get to June 7, you appreciate the fact that there's nothing to it really. It's not as complex as people will make it seem, or at least, I mean, from afar, if you're jumping into this area for the first time, it can be intimidating, right? There's a lot of new concepts, a lot of things that you have to, grapple with. But for the most part, we expect you to do things related to examples I'm giving. And sometimes, by the way, actually not sometimes, in most instances, the reason why my slides will have some of these things over and over again is I try to throw these things at people to say, these are potential problems that you can work on. They are there. And we know that most of these problems, data is readily available. We have partnered with most of these organizations, so getting access to this data shouldn't be a problem. A person like you who works for Ministry of Home Affairs, for instance, should be asking questions like, now I don't know if there's a unit, I think there is. These once upon a time there were questions raised about how if you go to a high density area like Ngombe, you will find CCTV cameras, right? But sanitation is a problem. I want to argue that the question we should be asking is, what are we doing by way of analyzing that information? Wealth of data, right? Are we even analyzing that information? If we are not, that's a potential open area. Now, one of the reasons why I'm saying are we is because I know that this is obviously sensitive. A person who would be interested in working in this area would probably need to maybe work for that particular ministry, right? Because it would be a lot easier for you to gain access to that information. But these are really thought-provoking questions that we should be asking ourselves. And if we were to discuss problems, we would spend the whole session discussing, there's a ton of problems. And these are just problems that I personally have come across. I would like to think that as we progress further, a number of you will actually highlight a lot more problems that in most instances will be specific to these environments that you work in. But anything that collects data, any environment that collects data is a potential candidate for you to devise problems to do with data mining. Not too long ago, we were interacting with a team from ZRA. We're doing training, we're conducting training. So UNZA was approached to conduct training. And part of my role really was to do training to do with, it was Python for data mining really. You'd be amazed, right? As to how things are currently done at ZRA. Like just projecting how much ZRA is going to get next year is almost manual-like, right? And these people collect a lot of information, trying to identify potential people that may be evading tax is problematic. One of the very first questions I was asking, because they brought sample data, right? One of the very first questions I was asking was, but how do you identify, you collect all this information about people that are paying, like how much tax these businesses are paying, but have you implemented models that are able to detect suspicious entities, for instance? The answer was no, right? All of these are manual-like processes. So I'm using ZRA as an example because it has come up here, right? It's not just drones. There's a lot, right? It's about the items that people import here, you know? How are they tagged? I think there's somebody who's working in this space, somebody who works for ZRA. But I think there was a question from Melvin as well. I'm hoping that I've answered your question, Chala.
Sure, you have, and I appreciate it. Thank you.
All right. I don't know if there's more questions. Okay. But anyway, so curiosity-driven impact versus curiosity-driven research. I want to argue that this may also be classified as curiosity-driven research, right? I don't know to what extent they were successful here, because for one, you'd have to employ people that are going to be manning the drones, and then you start analyzing image coming in from the drones. I don't know if it will be in real time or something. But what was reported was that they were able to capture. If you look at this news item from 2019, I think they managed to capture 7 trucks or something. I don't know how much money they got here, but I cycle around a lot, and this is what I see myself, not just near top plazas, but we see these things when we're driving past certain areas in the city. Gone are the days when we had those mobile speed traps, right? I know this one time I came across a company that was subcontracted by, I don't know if it's RATS or something, RDA, could be wrong here, but he was actually dismounting a mobile speed trap. I didn't know that those things were mobile. Yeah, so it's quite interesting here. But right now we have permanently mounted things. I don't know to what extent these things function here, but in certain segments, apparently they automatically capture license plate numbers of people that are speeding, going beyond the speed limit. If I were to make an educated guess, I imagine there's probably a custom solution implemented by an entity from outside that allows them to scan these things. I don't know to what extent they analyze this data, but hopefully they do this often and not reactively, where you only want to analyze this information if there's an accident, for instance, right? And all that. Again, this is what I was talking about, right? If you're driving through this area, you will find a bunch of things here, right? As a person who maybe works for RDA, I don't know if RDA is the entity that's responsible for these things, I would want a reconciliation of how much money versus the number of vehicles that have passed. Now, currently, if we were to ask RDA, how do you reconcile the number of vehicles that pass through here, number of trucks versus the number of, or the amount of money remitted? Don't know, right? How do we know that the amount of money that is deposited here actually matches with the vehicles that are passing through here? You know, but also I think you'd have you probably remember that at some point, these things, talking about being reactive, these things are quite instrumental. Data mining was instrumental in apprehending. If you remember, there was a vet doctor murdered not too long ago, right? I don't know if you remember that. There was a person who was traveling from Serenge or something, and he passed through one of the top plazas. And the only way they were able to at least apprehend the suspects is because of data that was being collected, or data that is collected here. There are cameras here, right? Aside from the fact that the license plate number is captured, they also capture your face, I'm guessing, or the inside of the vehicle. But anyways, again, I think these are things that I've already touched on. The fact that comments, right, would probably need to be analyzed somehow for you to do some comments analysis. Again, we can spend the whole day here talking about, different scenarios within which we can use data mining, insofar as Zambia is concerned. But what you will notice from all of these different things we've been talking about is that the common thing, the golden thread, is data. We cannot do anything without data by way of analysis. And what you realize is that the so-called data really manifests itself in so many different ways. There are images, there's videos. One would argue that video is actually a series of images, right? There's audio, there's text. The thing that is interesting is that irrespective of whether you are interested in mining text-based data or video footage or image data or audio recordings, the process is the same, and we will discuss this process. There could be a few disparities, so things like how you go about collecting the data, and more importantly perhaps the activities that you perform when you are pre-processing the data and cleaning it up, because cleaning up images is different from cleaning up text-based data, for instance. But what you realize is that the key high-level phases that you go through are the same, and we'll discuss these things at length. So data is key to data mining. I've already introduced us to Oxford Insights. I like to talk about Oxford Insights here because I would want to sort of like provoke this discussion. It's going to come up over and over again, right? Discussion centered around the fact that in as much as we collect a lot of data as a country, unfortunately, we haven't really gotten to a stage where we've deliberately put in place mechanisms, right, to accelerate this process, to formalize this process. And we see this from reports like the Government AI Readiness Index, for instance, where if you look at the current report, there's been very little change, right? So there's you'll notice that the number of pillars that they use to assess the AI readiness of various governments here. But what's important here is something I already mentioned, the fact that if you compare Zambia to countries like the United States, you notice the score for the US in 2022 was about 85%. This is out of 100, but Zambia was 29.63%. And again, if you look up government AI readiness index of 2023, you should have access to this information. I encourage you to go and look at this. The information that I currently have in the slides is as of before last year, 2022. I've attended certain conversations where I've raised this issue. Like I remember colleagues from Smart Zambia Institute were part of a panel discussion at last year's PACT conference, and I raised this issue. Hopefully this is something that they've incorporated into their strategic plan or something. I don't know, but I imagine very little has changed. We can probably try and see if we can check if the 2023 report is any different from 2022. We can just focus on the score, I guess. So the thing here, point I'm trying to drive at is if we're interested in impact-driven research, there are certain things that we need to have in place. Sure, we've mentioned that data is key here. But just because we are collecting data doesn't necessarily mean that we'll be able to successfully execute AI projects, especially projects that can potentially be integrated into government, for instance, right? The social sector, really. It turns out that there's more, that we need a commitment, we need policy in place as well. So if we scroll down to Zambia, where is Zambia here? Maybe we've jumped a node. I'm just going to search for Zambia here. I hope. So Zambia is, the score has somewhat changed, is it? I think this is the 32.6 here is, if I can come up to the header here, you notice the first column here with the figures is the total score, yeah. So Zambia has come down to, this is encouraging, 32.6 from a slight improvement. I don't know where the improvement is coming from here. This is from 29.63 the previous year. But still, there's more. This is a fail here, right? There's more we can do here. But really what's important, if you comb through this report, and I do encourage you colleagues to find time and go through that report. If you comb through that report, you'll notice that there's important things that will make us understand exactly why we are scoring that low. Like issues to do with governance and ethics, right? The capacity, maturity, human capital. This is a big one, right? We are collecting data, but how much of our workforce is actually able to work in this space, right? Do we have the requisite infrastructure? If you look at the health sector here, the answer is no, right? Issues of storage, data is deleted, availability of data, right? But anyways, also something else that will come up very, very soon, and as far as data is important, but if you look at the various phases associated with execution of a data mining project, we'll soon discover, I believe it's in module number 3, if we call it that, or lecture series number 3, we'll discover that the most difficult part, or the most involving, time-consuming aspect of data mining involves preparing the data so that you feed it into the overall model implementation process. So what generally happens when you're executing a data mining project is, first, okay, you do a bit of what's called business understanding. You try and understand the domain you're working in. So if I was working in the health sector, before I can even undertake the project, I need to understand the objectives, right, of the data mining project I'm undertaking. And that would require that I understand the domain I'm working in, right? Afterwards, I would find myself understanding the data I'm going to be working with, the data which will need to be analyzed. That's important because not all attributes associated with the data are relevant. You will soon see that a crucial bit of understanding, of data understanding, really involves you selecting the attributes that you're going to use. Once you do that and you collect the data, the next stage is preparing the information. So cleaning it up, right? Making sure that all outliers are excluded from the analysis. Making sure that you have a plan on how you're going to handle things like missing data. Making sure that if you're working with text, for instance, all the irrelevant aspect of data is excluded. Like if you're working with text data, comments from Facebook pages, right? If you're analyzing things like, I don't know what this is here, but it's from 2021 here, 700. If you're analyzing comments, you will soon discover that if you're really interested in, let's say, doing a sentiment analysis of the comments from people posting on these popular blogs, you want to exclude irrelevant words. Because you see, the analysis is not going to be done by you as a human being. As a human being, the word they and he and she and these are important parts of speech. But to a machine, to an algorithm, those things are irrelevant, right? So you exclude common things like common words, they're called stop words. Yeah? all of that is done as part of data preparation. Another crucial thing that you do as part of data preparation, as an example as well, is you transform the data, because the analysis of this data is done by a machine. A machine has difficulties understanding these things we're seeing here, whereas you and I can understand what is written here, right? Somebody has written this text. Honestly, this question is very tough and simple at the same time. When we read this, we understand this, but a machine does not understand this, right? It turns out most of these estimators or algorithms, you soon see, you're going to look at some of them, when you're using them, they require that the data being fed to them is fed to them as numbers, right? So for us to convert what you're seeing here to numbers, we have to transform this data, ideally. So long story short is that it turns out that data preparation is the most important aspect of this one. And please remember this, right? Data preparation. If you're one of those people who has experimented with data mining, you may not appreciate this, because what you have done actually is you go out there and you look for already available data sets. We found a data set that is associated with student performance, and we use transfer learning to implement our model, right? The link to the data we used is here. Well, in the real world, you have to do the collection of the data yourself, right? You have to clean up the data. You have to prepare it yourself. And hopefully once you get to that stage, you will also share it with other people so that they use the data and don't go through the problems you're going to go through. But the key thing here is the most time-consuming part here. Not implementing the models, not evaluating the results, not deploying. Certainly not deploying, really, to be honest. But anyways, on with that. And on that note, just to mention that as far as CSC 5741 is concerned, we are interested, the things that are actually stated in the program document as learning outcomes and objectives are the things that are listed on the current slide, right? So the thinking is that, or at least the plan for CSC 5741 is by the time we get to June 7th, or at the very least a week after or 2 weeks after, all of you should be in a position to identify the key processes associated with data mining. So we will discuss all of these phases. In our case, these processes will manifest themselves through a methodology referred to as the CRISP-DM methodology. There's a ton of data mining methodologies. We tend to focus on the CRISP-DM, and we'll explain why. We'll also look at, as part of our discussion of lecture series number 3, we'll look at some other methodologies that have been proposed. All right? We should also be able to identify key processes associated with warehousing and the ultimate knowledge discovery process, ideally. In addition, we should get to a stage where we're able to describe the basic principles and estimators or algorithms used in practical data mining and understand their strengths and weaknesses. Now, the good news, I don't know if it's the bad news, is that what we tend to do here is we gravitate more towards experimentation, evaluating, right? So given two alternative algorithms, right? Naive Bayes versus stochastic gradient descent, for instance. How do we empirically evaluate which one is better? Because it turns out that when you're implementing a model, you must choose. You must choose an estimator that you're going to use to implement that model. You can't implement a model that makes use of multiple algorithms, right? Before you get to a stage where you decide to say, I'm going to use naive Bayes, for instance, or stochastic gradient descent, we'll see exactly how we get to evaluate this. And just to give you an idea here of the extent towards which this, we'll go with this Python. I think I should be able to find the diagram I'm looking for. I like using this. It's a classic, this thing here. How you choose the right estimator, right? Because there's always this question of, if you are working on this is a question that they'll normally ask you, right? If you're working on a classification problem, right? Why did you use naive Bayes and not support vector classifiers or SVC, right? Or SGD, right? or k neighbors, for instance. Well, evaluation is the best way to get away or to run away from that question, right? So you conduct an experiment, a true experiment that will help you narrow down the appropriate estimator to choose, really. But that's neither here nor there. Anyways, also, though, we should be able to apply data mining techniques. So these key processes would have identified here should be able to get us to a stage where we are applying these techniques to solve problems in other disciplines here, in a mathematical way, right? I would want to argue that maybe we can replace mathematical in a scientific way. So once we understand what it means to execute a data mining project, all of us should be able to execute a data mining project, irrespective of whether that is associated with a problem in the humanities, a problem in education, a problem in the social sciences, a problem in the life sciences, right? The idea is the same. So you should be able to apply or map those techniques we'll discuss: data collection, data preparation, data transformation, modeling, evaluation, and deployment or something. And also, we should be able to apply data mining methodologies with information systems and generate results that can be immediately used for decision making. The key thing here, really, about knowledge discovery is we are interested in extracting insights. Whether what you are interested in is, or whether the problem you're solving is a classification problem where, we want to, we have a database of all students at UNZA, and we want to build a model that will tell us this student is more likely to steal or become a thief. Now, sorry about that. That's far-fetched. Or whether you are building a system which tells you to say, we've built a model that tells us to say, out of our current clients in a bank, this particular client called Chela or Mines or Fraser is more likely to become a very important client in the next 2 years. So we must keep them. They'll bring in money. It's a regression problem. Whether you're solving a classification problem, a regression problem, whether you're solving a problem where you have no idea what you're looking for, right? You don't know what you're looking for, but you have data. All you're interested in is finding patterns in that information. Those are clustering problems, right? The idea is the same. You're deriving insight. And you're deriving insight so that ultimately that insight is going to enable important people make decisions. If we discover that a certain segment of our subscriber base as MTN will leave in the next 6 months, we need to make a decision on what we're going to do. Maybe we will introduce a new package that will help us keep the clients or the customers. Anyways, but the key thing here is the basic principles will be introduced to us. Now, in our quest, gentlemen, to actually work towards these things, it turns out that we are going to loop through a series of, these are called lecture series, but I'd like to call them modules, if you will, because in some of these lecture series we'll be covering a number of topics. But ideally, the approach we're taking, in as much as at the very beginning it may appear that there's no structure, but what we're going to be doing is understanding what we are doing as part of the various phases of the CRISP DM methodology. So what do we do as part of business understanding, data preparation, modeling, evaluation, and deployment? Although we tend not to focus our attention on deployment, in part because deployment implies programming. The assumption we're making here is if you're enrolled into CSC 741, you know how to program. You can build a web service. You can build a nice user interface that can be interfaced by a model that would have been implemented as part of phase number 4, modeling. Right, so what we shall do, ladies and gentlemen, is we shall start off, and I think in the very next lecture series, we always have, this has become a tradition in the last 5 years since I've been teaching this course. We have what I like to call a gentle introduction to Python for data mining. And we call it Python for data mining and machine learning, but I want us to call it Python for data mining and artificial intelligence, really. So we focus on the very basic concepts that will make it possible for you to understand the things we'll be discussing, because certain topics we'll be covering will involve practical sessions. I shall also be sharing source code, right? And so for you to be able to understand those things, it's only fair that we go through Python. Now, I use Python as the best language here, but this is not a prescription. If you wish, you can explore using, other languages. Because machine learning or AI or data mining has become so mainstream, there are a series of packages that have been developed for various programming languages, right? JavaScript packages, for instance. But if you are looking at following through with the examples I'm going to be sharing, you probably want to follow along as we look at Python. So we'll discuss really Python, not just Python really, but what you notice is a number of other important tools, things that we think are important tools that you need to have in place before we start our discussion. And then afterwards, in lecture series number 3, we have a very lengthy discussion of the data mining process. It's called processes because at the very beginning, we start by looking at a series of methodologies that are available out there, and there are a number of them, right? So if you just look up data mining methodologies, or say popular data mining methodologies, right? And I guess this thing is maybe if we compound it with crisp DM, for instance, maybe it will know what we are looking for here. But what you discover is there's a ton of data mining methodologies. You say crisp DM versus KDD versus SEMA and whatnot. Maybe this will probably bring up results, gentlemen, that will have maybe examples of potential methodologies, right? That you can employ when you're executing a data mining project. Just because we're going to focus on crisp DM doesn't necessarily mean that that's the only thing that is there. Now, I do apologize that I'm using a resource from, is this Medium or something? I don't know if this is Medium. But what you will notice here is that there's a number of methodologies, right? I don't know if these are listed, but in here you have KDD, right? So we're going to look at some of these. KDD, the processes may manifest themselves in so many different ways, but the idea is the same. You're collecting data, you're pre-processing it, you're preparing it, you're transforming it, you're deriving insight. So that's KDD. This is SEMA. This is the crisp DM, which is what we normally adopt. You have crisp ML, for instance, right? Which focuses on quality of the machine learning aspect, for instance. So it's an evolution of the crisp DM methodology. But gentlemen, besides our discussion of the data mining processes, we will then have a lengthy discussion on what exactly we do when we are cleaning data. What activities are performed? What fancy things do we do? And what perhaps a key thing that you notice will come out of here is that the activities you perform are dependent on the type of data you are collecting. Text versus images versus audio, right? And then we'll have a discussion of data transformation. Really, what we do here is we just look at the techniques that we use when you are converting data, raw data, into numbers. So when you're working with categorical data, you'll notice that the transformation techniques are different from when you're working with nominal data, continuous data, or when you're working with dichotomous attributes, right? Male, female, pass, fail, versus rich, poor, wealthy, But anyways, and then afterwards, we'll look at model implementation. Really what we've done in the past is we don't really focus on the mathematical aspects of the estimators. I've been itching to have a cohort where we focus on this, but the thing is, I always hold the view that this space has evolved over time, and wasting time looking at, I mean, it's not that it's wasting time really, but I would much rather we focus on the high level things associated with model implementation. So the key aspects of what it is you do when you're implementing a model. Like for instance, if you're looking at supervised machine learning, you focus on things like how do you label the data, how do you train the data, right? How do you create a test set and a validation data set, right? And training data set and all those things. And then we'll look at specific approaches associated with deriving insight. Now, what we tend to do really is, when you're doing this, is we focus on the classics, because it turns out that when you're working on AI-centric or data mining project and you're deriving insight, you derive insight from a perspective of whether you don't know what you're looking for. I already mentioned. You're just interested in checking for patterns. Like we have data of all thefts reported at Kanyama police post or police station or Long Acres police station. Hopefully, some of that information has details of which part of Long Acres the crime was reported from, what type of crime. Now, if you have a lot of that information, maybe information going back to perhaps 10 years, what you may be interested in is patterns, right? You will notice to say, oh, we see that this area near Cathedral Hill has a lot of armed robberies or something. And those things will manifest themselves as clusters, right? Patterns, right? You can easily cluster that information. So because you don't know what you're looking for, you're interested in patterns, and hopefully the patterns will enable you make a decision. Like you have more patrols in that particular area, for instance. In some instances, you know what you're looking for, right? Like for instance, you are a bank and you have a number of clients. Maybe you want to classify clients on whether they are more likely to leave the bank. They're going to drop off or something. It's usually referred to as customer churn. So your interest there is, out of all your 1 million bank clients, you want to identify which ones are potential churns, right? So is it churn or not churn? That's a classification problem, right? So whatever insight is you're going to do, ultimately, it will be able to classify each and every client as being a potential churn or not. But also, there's issues to do with numbers. To what extent do we expect government to increase salaries in the next 2 years? It's a regression, right? Because you're looking at a continuous variable here. But anyways, the point here is that we focus our discussion on looking at how we implement linear regression models or regression models, how we implement classification models, so binary classifiers, multi-label classifiers, multi-class classifiers, and then also look at clustering. Granted, there's a series of, I guess what you might call other things that you can do, but we only focus on the classics. And the thinking is always that, you see, if we cover all of these things, we'll be able to get you to where we think you need to be by the time we get to June. So you should be able to execute a data mining project. Now, again, for theme number 1, we're looking at Python. Just to mention, give you a sneak preview of what we're going to cover in exercise number 1. We'll look at tooling. So the tools that we're going to be using, tools for reproducibility. Notebooks have become the in thing. So if you haven't used Jupyter Notebooks, or if you've not used Google Collaboratory or Google Colab as it's commonly called, we'll have a crash course introduction. Most of what we cover really is to do with Markdown, if you will. It's a markup language. So we want to get you to a stage where you're able to, ladies and gentlemen, get to create something like, so if you go to collab .research, I believe, .google.com, I think it is. I don't know. You should be able to, if I look at this here, we should be able to create a notebook. The idea behind the notebook is similar to the notebooks we were using in class, or the notebooks we use, right? You write down things. In this case, would be source code and other textual information, and then later on you can share this with somebody else who'll be able to run these same things on their computer or something, on their machine. Reproducibility. And then we'll have a crash course introduction to Python, really just installation, the very basics. So we'll look at data types and data structures used in Python, flow control, functions, and for us, more importantly, this notion of modules, because we want to be able to import modules. So if you run your Python interpreter, however you're using it, you want to be able to import these different modules, right, and be able to use them effectively and look them up, so that you check, what specific aspects of the modules you'd be interested in. You should be able to download the modules if you don't already have them, because some of them don't come bundled with the language itself, right? Like scikit-learn, which is a classic library that we need to be familiar with. This needs to be it needs to be downloaded and installed in a certain way, right? Okay, and then we'll look at some important core Python libraries that are relevant to what we're going to be discussing. Like, for instance, there are toy data sets, obviously, but also there are libraries that will help when it comes to visualization. You see, what you discover is that when we are looking at specific portions of a typical data mining process, like evaluation, like data understanding, there are things that we need to do, like we need to visualize the data, for instance. For you to visualize the data, what that means is you're drawing graphs, right? Now you can draw graphs in Excel, but if you're handling millions of records, now you know that if you have experience with Excel, it will hang or it will crash or something, unless if current versions of Excel have become more superior. But we'll look at some of these core libraries that help with these processes, like matplotlib for graphical representation, Python pandas for pre-processing data and transforming data, and scikit-learn for model implementation. Okay, that's not to say that these are not the only thing. These are the only things that you'll be able to use here. And then, as part of theme number 2, where we're looking at knowledge discovery and data mining processes, like I said, we focus on the CRISP-DM model, and we essentially we're going to study these 6 phases at length. Now, our experience has led us down the path where we've noticed that it becomes very helpful, colleagues, for us to use test cases. So there are specific test cases associated with projects that we've executed in the lab or projects that I've been a part of. I apologize that a number of these that involve the use of text here, but the data is readily available and it's not that sensitive. So we're going to look at all of these different phases, and then in theme number 3, if you remember, we look at data cleaning and pre-processing. In essence, what we're going to be discussing is the 3rd phase of the CRISP-DM model. So we'll have a discussion. This will be a repeat for most of you in your statistics or in your research methods course at 4th year. You will have no doubt have been introduced to types of data attributes. Ordinal versus categorical versus dichotomous versus continuous attributes and all those things. Images, right? Video, the video images, right? And then we'll look at how we clean data, right? We'll look at generic preprocessing tasks like deduplication, so removal of duplicates, handling missing data. You have got to make a decision. Do you exclude observations that have missing data attributes, or do you instead come up with a default value, a filler attribute? All right? We'll have a series of practical walkthroughs here so that we understand. And then we have a discussion centered around what's called exploratory data analysis. So it's notion that at some point you need to have a high-level overview of the data you're working with. It turns out that that process needs to be systematically executed, right? So the good news is that this is again a repeat of what you did in your stats course or your research methods course. We mostly focus on descriptive statistics and different types of visualizations, bar plots, pie charts, line graphs. In some instances, you perhaps need to render actual images. And we emphasize the use of graphical techniques here. And then, in theme number 5, we look at data transformation. Now you notice that I'm highlighting specific phases of the CRISP-DM model where all of these different lecture series will be discussed, right? Because it turns out that in as much as these are so like contiguous or separate concepts we're discussing, but they may actually fall under the same phase of the CRISP-DM model. All right? So after exploratory data analysis in lecture series number 4, in lecture series number 5, we discuss data transformation really, where we look at how we go about transforming the different types of data attributes. We introduce techniques, classic techniques like tokenization, popular models, especially as they relate to text data. So the bag of words model, for instance. And models such as the TF, IDF, or term frequency inverse document frequency model, if you will. And then in lecture series number 6, we go through a process of how we implement machine learning models, right? Remember, for us to be able to undertake classification, clustering, or regression, what this means is we're building AI models, right? We call them AI models here. The question is, how do we build these AI models? Well, we'll learn how to do that in lecture series number 6. But what you discover is that there's a lot at play when you're building models, right? It's not just a process of just, I built a classification model, right? We have to learn how to evaluate the model, how to experimentally evaluate the model, how to train, especially for supervised machine learning, how to train these models. And then finally, in lecture series number 7, we look at specific examples of types of AI models, right? So, or machine learning models, so regression, this is classification, this is clustering. Now, you see, again here, in terms of going forward, because very, very soon we're going to have these assessments, right? Invited speakers and all these things. I understand that we are busy, just like today, perhaps there are some of our colleagues that are busy and we're unable to attend class, but for this to work, right? I think it's one of the easiest courses. If I look at, especially if you look at the technical aspect of the course itself, okay, maybe not, I don't know. But it's probably one of the easiest courses. The only thing you need to do, especially if you're doing this for the first time, is you want to make sure that you attend classes, and if there's an assessment pending, start working on it the moment it's open. I think that's a recipe that works really. But beyond that, I was hoping that as we start our discussions, and we've already started our discussions here, if I were you, I would already start thinking about potential areas. Now I know our research methods course is where we are taught how to frame problems. But that doesn't mean that you cannot already identify a potential problem space you can explore. And I always tell colleagues enrolled in this course that the best place to start from is your workplace. Because you understand it better. You're a domain expert, actually. And when you're a domain expert, it's extremely easy for you to identify problems. The only missing ingredient from, at least insofar as what we're discussing is concerned, is the fact that the missing link is the solution. If I have this problem at work, how can I carve out a data mining centric solution? This is what we're going to be discussing in this course. And unfortunately, in the course, gentlemen, we do not really look at how do you find out a data mining project, right? But as we are reading through paper reading sessions, the hope is that you'll be able to relate what other people are doing, right? To a potential problem space. Oh, maybe I can apply the solution that was proposed by these authors into this problem that I'm looking at exploring. So research focus here. And if you do that, you will find that by the time you're getting towards the end of the year, you would have already identified a research problem. All you have to do is package it in such a way that it fits into your research proposal. Okay. The other thing you can do is you can already start going through important documents like or literature associated to the SDG goals, or you can look at our very own Vision 2030 and see if there are things that appear in there, that can be addressed using data mining or using a data mining centric solution, especially that we're only remaining with 6 years before we get to 2030 here. So yeah, really, if you're looking at passing this course, really my advice to you is just make sure that you attempt all the assessments. If you do that, you will pass this course, right? We don't expect people to fail at this level, to be honest, unless if you're really neglecting work. Because if you're neglecting work, you will find that the test is going to be incredibly difficult. The exam will be difficult. You will fail to work towards assessments, and especially the practical mini project, and hence you shall fail. And of course, we've already mentioned that academic dishonesty is not tolerated, so any form of cheating. Before we get to the second part, colleagues, you see, I wanted to find out if perhaps you have any specific questions about what we just discussed. It was just a gentle introduction or overview. Please, Brian, fire away.
Thank you, Doc, and good evening.
Good evening.
Yes, I just want to find out, for example, when you want to do a data mining project.
Yes.
Obviously, we've been talking about subject-oriented. Yeah. Now, in this case, so for example, maybe when you talk about crime trends.
Yes.
So for crime, it's actually a generic word. So you find that there are various types of crime included.
Yes.
So now, if for example, one wants to do a crime trend analysis, to derive a pattern of crime over a certain period of time. So does it mean that, for example, you have to focus on one type of crime, or you look at it from the horrific point of view? Like, for example, maybe some of the crimes that are there, like let's say robbery, or you look at it on the horrific level. So I need guidance on that one.
Excellent question. And you see, this question, the question you raise is important, right? If you take time, and I hope you've already taken time to do this, because I believe colleagues have introduced you to the repository, where you yourselves, right, can already start looking at what other students have done in the past. What projects have they done? Now, if you start looking at the projects, right, and in fact, if you find time and attend the Viva Voices that are going to be held in the next coming days, colleagues, for the department, you see, you will realize that the focus is different. The problems that students work on are different. In some instances, actually, we will sit there in an exam and you say, but the previous speaker seems to have done a very trivial problem, right? When you're doing research, unlike the test and the exam that we're going to write, everybody's going to write the same test, right? The same exam. But for research, we will be working on different problems. Some people will choose to work on very hard problems, right? Because you choose, nobody forces you actually, you choose yourself. But the point you raise, Brian, focuses on what's called scoping. Now, the idea of scoping here is multifaceted, right? But an important point to stress is that one of the reasons why you are assigned a supervisor or supervisors is in part to help you with scoping. Because what generally happens is when you start executing a research project, usually people that are doing research, mainstream research like this for the first time, will get excited. Like the example you gave, right? I am going to analyze crime trends for the whole of Zambia. Really? Okay, for the whole of Zambia, that's at the beginning, right? Now, if you sit here and you say the whole of Zambia, you begin to realize that the things that you uncover, and that's interesting, everybody will be so excited. And this is for a master's program. Everybody will be so excited. Oh, this is an interesting project, right? But the question to ask yourself is, how much resources are you going what resources are you going to require for you to analyze trends in the whole of Zambia? You know, as a domain expert, that for one, this data is not readily available. It's not in digital form, right? So part of what you're going to do here is go through the grueling task of digitizing this information, right? Classifying it or something in a certain way, transcribing the information. So the thing about what is too much, because your question is tied to what is too much and what is too little. Well, when you're presenting, so this starts with your supervision. As you're interacting with your supervisor will advise you to say, so there'll be things like things thrown around like what you're proposing in terms of scope is not worthy of a master's degree. Or he would say things like, I think we are biting more than we can chew here. So maybe what we should do is we should reduce the scope. Rather than focusing on the whole of Zambia, why can we not just look at Lusaka? Or why can we just not focus on urban areas? Or like you rightly put it, why can we not just focus on mapping a specific type of a crime, maybe armed robberies or something? But again, the issues to do with scope, your supervisor helps you, because sometimes some of the things that you are suggesting or planning to do may be trivial, right? It's something that, if it's something that can be done in a month, for instance, then scope needs to be increased. So maybe your supervisor will say, I think this would be more interesting if you focus on the whole of Zambia, because the patterns that we are able to extract from Zambia as a whole will be different based on the different areas. High density areas versus low density areas. High density areas in Lusaka versus high density areas in Mongo or in Kasama. Because it turns out that when you're undertaking a project at this level, it's a research project, right? People are interested in the process, the science. This thing we are learning as part of data mining is a means to an end. What we are looking at is the science, right? Research questions. And in most instances, these research questions will, maybe only one of the specific objectives will be tied to implementation of a data mining solution, for instance. So I hope that answers your question, but the scoping is done alongside your supervisor, right? Which is why you are asked at some point very, very soon, prepare a research proposal. In that research proposal, you have, this is our main objective. Our main objective is to understand or to analyze crime trends in Zambia. Our specific objective are as follows: to digitize paper-based records or crimes reported to police stations and police posts in Zambia. Number 2, to implement a clustering algorithm which will enable us to derive insight. 3, to evaluate the patterns, because you discover that when we look at unsupervised machine learning, this is where clustering falls. Usually when you identify clusters will be regions or data points that have things in common, certain things in common. The people that will be able to tell you to say these patterns have something in common are experts usually. But if you're a domain expert, obviously you'll be the expert, although there's a bit of issues to do with bias. Now, I hope I've answered your question there, or hopefully in part, but I don't know.
No, thank you very much. You have fully answered it.
Yeah, and more actually to be answered again in your research methods course. And I believe the research methods course is in the second half of the year, so it's in term number 2. Anyways, I don't have any other thoughts or questions. I thought we would, I believe the remaining parts, part 3 and 4, are quite short. I'd actually hoped that would finish our discussion of this lecture series in good time for us to transition into the next lecture series, which involves a bit of Python programming, but it appears we'll just have to start this on Wednesday, colleagues. But if there are no questions, then maybe we can just go to part number 3. Now, a reminder, colleagues, that part number 3 is tied to an assessment which will require us to go and do paper readings. So there's an assessment category where you are supposed to summarize readings that will be shared with you, right? And to ensure that we are doing the correct things, we just have a brief discussion about this, because a synthesis of a reading is not just a data dump, it's supposed to be a critique, right? And just to give us maybe a sneak preview of this, I'm just going to go to I think, I do believe may have samples from the other year. I'm not sure. Let me just check records from last year. I hope I have these records. I always keep these records, but I'm not really sure if maybe under paper readings or something. I thought there was a sample here, but so what I'm going to do is again just gravitate to last year's records and hope that I'll find exactly what we are looking for here. We normally have these somewhere here where we have a sample as 2. I don't know if we have sample here. It has 1. So which is this. I'm going to copy this link. You see, when we have an assessment by way of a paper reading exercise, what we ultimately expect you to produce is something similar to what you're seeing here. Now, this is an example from one of the previous years. I'm going to blow it out. A summary, it's a short summary, usually no more than a page, but the assessment, the rubric is shared, obviously, in the assessment. So you'll notice in here that you're told to say the grading of the paper submission is based on these aspects: accuracy, coverage, the arguments you present, adherence to the prescribed layout, just a general presentation of the paper, and any personal reflection. Now, the thing is, the discussion we're having right now is meant to remind us to say, when we are reading, if you remember our discussion of research methods in undergrad, they told us that when you are reading a research paper, we don't treat it like a magazine or a newspaper article, right? It needs to be done in a systematic manner because there's specific information that you're looking for. But the first advice we have for you really is that when you're doing this, you probably want to probably familiarize yourself with the bibliographic management software too. There are a ton of these. They are called bibliographic managers. The thing with most of these tools is, I don't know if I have Mendeley installed here, but they're I haven't yet. But they're designed in such a way that they have features such as, highlighting. You can highlight content. Maybe I can install Mendeley. I've been using Mendeley, but since it was acquired by Elsevier, It's still free. Maybe it's time I migrated to perhaps a different tool here, maybe Zotero or something. But the idea is the same. All of them do the same thing. No, but not this. Linux, thank you. And I'm going to download 64-bit here. Now, this will take a while. It's 195 megabytes. So, a bibliographic manager really helps you organize your work. One of the things you realize as you are reading, or if you remember from your 4th year, is that when you are reading scientific literature, some of the things that you do is as you are reading, you highlight, right? So you typically print it out and then you're highlighting and, scribing somewhere in the margins of the paper. Well, but colleagues, this is 2024. Nobody does that anymore. So you can use this bibliographic manager to keep track of this information. The sooner you start teaching yourself how to use these tools, the better, because when you invest time in some of these tools, it will become a lot easier, or a lot of things that you'll be doing as part of the research part of your program will be so much easier when you get to next year. So please, colleagues, you may want to look into Mendeley now. You see, the thing again is that if you just look up bibliographic management software, if you just say list of bibliographic management software, go to Wikipedia, you will notice that there's a ton of tools. I cannot claim to have used all of these tools, but I have used JabRef, right? Because I once upon a time I used to be a fanatic when it comes to authoring documents. So I would not use Microsoft Word, I would typeset documents. But I have since seen the errors of my ways, and I now use simpler tools. But I use PaperPower a lot. The thing I like about PaperPower is that, forget about the fact that there's subscription fee required here, but the thing I like about PaperPower, colleagues, is that I can integrate it with Google Docs, and I work a lot with Google Docs. I also collaborate with a lot of people. All right, so I'll give you an example of something we are doing with one of the students I'm working with. Now, this thing here, because this student is used to Microsoft Word and all those things, and because we're working together, we can't be working in such a way that she does something to a Microsoft Word document and then she uploads it to Google Drive or sends it via email. What we do is we collaboratively work on this, right? So you'll notice that there's Matilda appearing here and my name, right? We are working on this collaboratively. Now, when we're doing this, because we are authoring a paper, colleagues, at some point we need to add references. And it turns out for us that we are using PaperPower to do this. It's a bibliographic manager. I'm just giving you a heads up to say part of what you can do as you're reading for this is you can use PaperPower if you wish. Now, I'm not sure about the part where highlighting comes into play. You may not have those features, but what I do know is that a tool like Zotero does have that feature. I've used Zotero before. Quite useful. You notice that there's a Firefox and a Chrome plugin for Zotero, and also you can synchronize stuff to the cloud just like Mendeley as well. I've also used RefWorks. It's proprietary. This was the bibliographic management tool of choice for my alma mater, so they would pay licensing fees for staff and students to use this tool. There was licenses for students and staff, but the long story short here is that the long and short of it really is that you need to invest time in your bibliographic manager, and a nice starting point, I want to encourage you to use Mendeley. I don't know why this thing just stopped here. I want to encourage you to look into Mendeley, or Mendeley Desktop as it is called, and you'll probably remember and appreciate that I offered you this advice. The other thing here is, you see, when you're reviewing a paper, part of what it means for you to, if you look at the rubric, for you to present arguments and personal reflections, this may entail that you look at what other people have done relative to that paper that we are reading, not just the references. And so you may perhaps want to look at specific types of academic databases, like Google Scholar, for instance, or ArtMiner, right? This is more focused. You'll be able to find, or the ACM Digital Library, for instance, you'll be able to find information that is specific to computer science. I've included hyperlinks to all these different platforms. In some instances, there are people like Jeff Huang who have curated lists of classical papers that you may want to refer to as you're summarizing these papers. But also, of course, especially as it relates to personal reflection, you may want to contextualize whatever is being, whatever is associated with the paper linked to the assignment, the active assignment. You may want to relate this to what is being done in Zambia. And the best place you can go to is our very own Zambia ICT Journal. All right. So the Zambia ICT Journal, gentlemen or colleagues here, it's regularly updated. I forget how many issues are produced each year. But if you want to have a sense of what people are doing in terms of research to do with ICTs in Zambia, I encourage you to find time and look at the Zambia ICT Journal. Again, I've shared the link there. You see things like assisted artificial intelligence medical diagnosis systems for heart disease. All right. You have things like predicting climate change related extreme natural disasters using machine learning. You know, challenges using data mining techniques to analyze and forecast COVID-19 pandemic. So a lot of interesting things that you'll find, especially as they relate to reflection. In terms of my advice on how to read, really, I always joke about this because there are a number of courses where I'm teaching research-centric courses. I teach a second-year research methods course at undergrad, and I'm also coordinator for a capstone project course. And I always joke to say, I strongly recommend that you read the how to read a paper so that you understand what you read. Now, I like referring to Keshav's approach, right? It's a 3-pass approach, he calls it. And the 3-pass approach allows you to understand the various papers of a paper. A typical paper will have certain key elements, right? If you open up at any research paper, now some of these things may not be explicit like this, but what you will notice is that they will all have something in common, and that will be an abstract, a summary of sorts of what is in the paper. There will be an introduction to provide some contextual overview about what the paper is about. There will be a related work section citing key work related to what was done. There will be a methodology section outlining the approach used to execute this project, what exactly was done. And then there will be a results section. In some instances, results and discussion are combined. In some instances, you have the results section and the discussion section. And then finally, you will have a conclusion section. Now, you see, if you look at a typical paper, right, it's usually quite lengthy here. Typically, a paper, depending on whether it's a conference paper or a journal paper, can range to anywhere between 5 to maybe 20 pages. Now, the key here is to focus on the relevant things, especially when you're just looking at maybe literature to help you prepare, let's say it's a reflection or something, right? Or prepare solid arguments, right? Keshav proposes a 3-pass approach. And according to him, the first time you're reading a paper is just scan through the title, read the abstract, which is usually anywhere between 250 to 500 words. Read the introduction because it will have background information and things like background information, research questions and objectives. So if you read the title, abstract, and introduction, and then you go through the sections and subsections, just reading the titles of sections and subsections, and then read the introduction, read the conclusion, and then go through the references. The idea, according to Kishav, and really if you follow Kishav's approach, is in the first pass, you'll be able to classify the paper itself. What type of paper is it? And in fact, you'll be able to contextualize the paper itself and be able to determine the relative levels of correctness of the paper and the key contributions as well. And other important information like whether the paper is clear or not. In some instances, right, in the first pass, you can easily write your paper reading assignment using this. But if you still don't understand the paper, in pass number 2, you go a step further. This time around, you look at floats, right? So graphs and tables and equations that may be there. So in the case of the paper I was giving as an example, the first pass, just read the entire abstract, all of this. So this, you read the entire introduction, all of this. You then, after you read the entire introduction, you just read through the sections, not the contents of the section. So you just check what section 2 is related with methodology. Under methodology, there's research approach. You're just scanning through, right? Study context, okay? They looked at student performance, factors influencing learning outcomes. If you want, you can read portions of the introductory text here. But the thing is, you don't want to waste time doing this. And then you read the conclusion. In pass number 2, what he's saying is you go through the floats. The floats are figures and tables and equations. So you go to table 1 and see what this is about here. You go to table 2, what is this about? You go to table 3, you start going through the graphs. Oh, there's figure 1, okay. There's figure 2, what is this about? There's this weird table here. Table 4, what are these things here? Yeah? What is this graph about? Anyways, so that's pass number 2. And here, when you get to pass number 2, if you don't understand what the paper is about in number 1, by the time you get to number 2, you will have a firm understanding of the paper. If you still, your understanding is still a bit sketchy here, you go through a second pass where you thoroughly read through the paper, and at the end of this, you'll be able to identify the fundamental flaws with the paper, the gaps. We don't do that under the paper reading assignments, but when you start your literature review, when you're doing a literature review, you better get to pass number 3, because part of what you're looking for are gaps in existing literature. So a pretty easy to follow 3-pass process. And the best I can do is tell you to say, go to the ACM Digital Library or just go to Google Scholar, colleagues, and search through how to read a paper. And just make sure you search through Kishav, and it's right here. And you see, it's quite popular here, 229 citations. And then that's it. If you want a direct link to the PDF document, I will share it in the link right now, but it shouldn't be difficult for you to find the how to read a paper. I've shared it. And you see, colleagues, I know it's a paper on how to read a paper, but if I download this P83 and open it up, you will notice, colleagues, that it's just 3 pages. 3 pages. Page number 1, page number 2. That's it. And page number 3. And page number 3, it's actually 2 pages because page number 3 is just references, really. Colleagues, so that's the how to read a paper. It's a classic. I always refer students that are getting started with research to this paper here. You can go a step further and look at also reading a computer science paper, because the how to read a paper just looks at how to read a general scientific paper, but reading a computer science research paper is more specific to technically inclined papers. So again, you can go to Google Scholar. I don't know if I provided a link, but I just have screen grabs here and say reading a computer science research paper. This is also a classic, right? You want to go through, where is that? I wonder if we can do a verbatim search here. Never really. There we go. So one by Fong. Again, not as popular here, but there's a direct link. I wish I could say this is also a short paper here, but this is 6 pages. Again, this is not difficult to follow really, but you will notice that maybe the information that you will get here is going to be slightly different, colleagues. It will be different from what you will get from the how to read a paper. So if you open up this, you'll notice that maybe the information that we'll be able to get from here may be slightly different. I don't know. You know, anyways, so that's that. I don't know if there are any thoughts or questions about this part here before we transition to, this is just a short part here, or maybe I'll leave it at the end of part number 4 here because it's a short one. I just want to encourage you all to please attend these public talks. For one, you are paying money to gain access to these resources. Now, if you are paying money and part of what you are paying money for is to be able to attend academic events, which, by the way, these are public events, why not attend them? I think after next week, if my memory serves me right, we should have oral exams for computer science students. I will push that the meeting link be shared because things have become a lot easier. A lot of our students sometimes will not be based in Lusaka, and so the exams are done virtually. And because they're done virtually, you don't have an excuse. There was a time when, you know, the excuse would be, I cannot make it to Unza Great East Road campus because of work. But this time around, you can just fire up your phone and plug in your headsets even whilst you're at work. So you're doing work and you're just keeping an ear out to what is being discussed. Who knows? Maybe there'll be a topic that will draw your attention. All right? So please find time to attend these talks. They are public talks. Sometimes there are renowned researchers that will come through. These are always shared by public relations. I'm not sure if you are part of the public relations mailing list, but usually public relations will send email from here. So if you have your CS email account, you no doubt receive. Look at this already. When was this? On the 3rd of, colleagues, on the 3rd of April, their PhD defenses. Examining the mechanism of student loans, economic growth and poverty nexus in Zambia, evaluating motivation factors in Botswana's public employees, you know, effectiveness of POGIO in biochemistry, enzyme kinetics, whatever, exploring gender mainstreaming implementation. So these are all things that, I don't know if there's anything technical here, but these are all things that you want to attend because sometimes, right, and this has happened to me, I attend a presentation and there's something of interest that is discussed and I realize, wait a minute, maybe we can incorporate some aspect of computing to this problem. Who knows, right? So there are a number of public talks, and then also a special type of public talk are the oral exams I was talking about. The reason you want to attend these public talks is whether you like it or not, you yourself will be doing this. Now, if you know that you're going to be doing a public oral defense, why can't you attend so that you see what the current students are going through? So that you avoid the mistakes they're making. You know, I would attend if I were you anyway, but of course I'm not you here. But and really it doesn't matter if the public defense is in is in a different domain, you know, School of Engineering had public defenses. Just attend, right? Because science is science. Research is the same. All right? You'll be able to maybe pick out things that you are not familiar with here. This is outdated, but as soon as the schedule, colleagues, for this year's exams are shared. It's usually something like this. I shall share it with you. I shall, or perhaps reach out to the course rep so that he reaches out to the postgraduate coordinator so that he formally invites you to attend these things. There's usually postgraduate seminar weeks. These are because of decentralization of the Directorate of Research and Graduate Studies. Now these seminar weeks are held by respective schools. There's a seminar week for School of Natural Sciences. If I were you, I would follow up with the course rep and say, can you find out from the postgraduate coordinator, Professor Piri, when exactly postgraduate seminar week for the School of Natural Sciences is, so that already as a group you can map out, you can already have details of this information so that you plan ahead. I want to leave it here and just kindly ask colleagues if there are any questions. Now, I'd have to apologize. This is 1920. We could have transitioned to the next lecture series, but no rush. We shall just start it on Wednesday, very, very soon. I don't know if there are any thoughts or questions about this. All right. If there are no thoughts or questions, I just wanted to also mention that hopefully very, very soon I want to draw up a schedule of invited speakers. So these seminars for CSC 5741, remember they count towards the course score. So as soon as we have a schedule, you can also plan ahead. There are marks, a reminder, allocated to attendance and also participation. All right. On that note, sorry that we had to force you guys to attend this class during Easter holiday, but even if you're in Samfia or I don't know where people go here, is it Siavonga or Livingstone? Wherever it is you are, hopefully this was fine. This was not too much of an interruption, just a little over 2 hours here. Thank you very much, and we'll see you on Wednesday. I'll try as much as possible I always try to record interaction, so this was being recorded, and I share these recordings on the class Google sites. I mean the Google Classroom site. I'll process this and upload it and let you know as soon as this is shared. Thank you very much, and enjoy the remainder of your 4 days holiday. Thanks.